Welcome to IT Pro TV. I'm your host, Don.
Coming at you live from San Francisco, California.
You're watching IT Pro TV.
Hello everyone, welcome back to another exciting edition of IT Pro TV. I'm your host Vaughn Smith and this is our Cisco CCNA series and this is for exam 200-301. We are in our network topology architectures and we're going to take a little bit closer look at the data center. And here he is to help us out, Mr. Ronnie Wong. How's it going for you today?
Well, Vaughn, it is going very well.
It's going?
Yes. And thank you again for joining us on this particular unusual day as we've got started here a couple of different times. But as we get started, we do want to dive into the realm of the idea of the data center and understand the types of topologies that you and I will encounter. Now, we're not going to go into a super deep dive in this, of course. But what we want to do is we want to make sure that you understand if you end up getting hired and working inside of a data center, these are kind of the logical topologies that you're going to actually end up running into. And so we want to make sure that you at least have an understanding of that right now, okay? So when we start to think about that idea, okay, that context matters, right? So in other words, the architecture that you run into and how devices are cabled together and how they function together, they're actually going to work a little bit differently depending on that environment. And the data center is probably one of the more popular environments today because you can go very extreme. So if you think about the idea of Google or Microsoft's AWS or Microsoft's Azure, Amazon's
second. Isn't
AWS.
That Amazon?
You're right. Yeah, man. If I can mess up anything, I can do that. So when you start thinking about the idea of cloud architecture, we're really talking about huge, gigantic data centers that are out there in the world today. And it is possible that you could get hired to work in one of those. But a lot of times it might be, especially if you're at the beginning of your career, where you're going to get hired for something a little bit smaller, but they'll still have some of the different types of structures that we're going to be talking about today. Now, if you're like me, you actually ended up working in a small to medium-sized environment, and you actually had a different architecture there as well. So we'll be covering that too. And then lastly, we'll talk about what in the world the future is actually bringing, and already here as far as the really big centers that are out there, which is called the spine leaf architecture, and we'll be talking about that as well. So Vaughn, there's at least 3 different architectures that we need to understand. So does that sound like some fun stuff for us to learn?
Yes.
Yes. Yeah. So Vaughn sounds exciting. So let's go ahead and get started then.
I'm always excited when you are here, Ronnie, because you know why? Because I actually learn a lot from you, Ronnie.
Well, great. All right. Yeah. So let's go ahead and take a look then into the realm of what we want to start off with first, okay? So this particular model that we're about to see is probably the most popular model that's out there. So let's take a look. And it is called the 3-tier design model when it comes down to data centers. Now, Vaughn, as we take a look at this has actually been Cisco's kind of way of actually designing and connecting network topologies together as well. Now, we all understand something that there's actually different, physical layout topologies that's actually out there. You've heard of the star, the bus, the ring networks. All those are things you've probably learned about if you studied something like the CompTIA Network Plus and the A Plus. All these are actually fairly, popular types of technologies. But once we move into the realm of the data center, Vaughn, I can see a couple of those actually ending up working here to a point, right? So I can see like the idea of a star topology, even off of something like the distribution here, okay? So Vaughn, if I take a look at just that, notice it's connected to every other device that's out there except for this guy right here, okay? But overall though, we have something like a star in that. But Vaughn, I can also see the idea of just a simple point-to-point connection that might be there. I can see other types of topologies that we talk about. But when it comes down to data center, we may be using all those together with different types of equipment. So Vaughn, as we start to take a look, notice that down here at the bottom we have what we call access layer types of switches. And this is where we normally will connect endpoints. So this will be things like server workstations or servers. Okay, in other words, rack-mounted types of servers is what we normally think about. So we're no longer talking about the idea of the servers in terms of software that's actually providing a service of some sort, but we're normally talking about those machines that normally fit into a computing rack somewhere as well. Now, once those servers are connected and there's multiple machines connected to each one of these switches, well, for them to begin to function, if they're only talking between each other, they only have to hit this access layer switch, and that's perfectly fine. But what if they need to connect over to another switch, such as a server over here on the second switch, or even over here on the third switch, or over here on the fourth switch? Well, that's when they might actually have to head up to the distribution center as well. And from that point, they can actually run the distribution. Or if they start sending a tremendous amount of data, it goes across the actual core layer as well, okay? So this is designed for high-speed backbones is what it's designed for. Distribution, of course, allows us to get beyond our one physical switch too, okay? And so everything looks fine here, Vaughn, when we start talking about that idea of the 3-tier data center, okay? So it's broken down in this idea of access, distribution, and core. So that's actually kind of key terminology that we want to know. But Vaughn, when we take a look at all this, there's something else we need to notice about this particular type of design as well. And this design, if I can actually select the right thing that I want to, so we'll actually take a look at the idea of a pen. Vaughn, a lot of these links are actually going to be, well, redundant for right now, okay? And what that means is that once we start hooking up switches, there's something else that comes into play, which is the idea of spanning tree protocol. And what spanning tree protocol does is it finds the best path to whatever destination that we're going to. So Vaughn, let's say that we want to get over to this particular switch over here, okay? So if we want to do something like that, I wish I could have picked a better color or pen here. Let's see if I can do that. I don't know if I can. Oh, actually, I picked a disc there. That's not exactly what I was hoping to do.
Just change the fill color, the one to the next.
Ah, the fill color.
Yeah,
there we
take
go.
that fill and make it none.
Oh, make it none.
Yeah, that way it
Let me
looks just
try
like
and
an
do that.
pen.
There we go.
There you go.
So, you are correct. All right, so let's go ahead and do that. So let's say that we want to make it to that switch there from this guy. Now, Vaughn, it seems easy enough. I should just hit the distribution layer and come right down because I have those connections. But the way that spanning tree works, it says I want to find the best path through, and that means that the rest of these are going to be blocked. So a lot of these are just redundant while spanning tree is going on. So let's say that these two can get blocked, or maybe even, oops, did something bad again.
No, it just wanted you to move that.
Let me do that as well. And so Vaughn, I've now blocked off those three. So if I want to get over to that switch, I'd have to come up through here. Maybe I can go this way, or I can even go this way. Oops. Or I can try and go this way as well. But Vaughn, one of these is probably going to be blocked as well. So let's say that this one's blocked. So Vaughn, now that means that I have to come through here, and I now have two choices again. So one of these may be blocked before I can do that. So Vaughn, in other words, my path to be able to get to where I want to go is going to actually come and go like that. Now, Vaughn, when we start doing that, and that's because of the way that it's set up in the technology in the background, is preventing switching loops, okay? So it provides only one path through the entirety of these things, or we might get into a loop here, and it might go around and around in a circle forever.
Okay, that's what I was just going to ask about, like, when you're saying they're blocked, it's because of this protocol to where, like you just said, if they're all open, then it's just going to be,
yeah, it's just going to continue to circle around. Okay?
Okay.
So even in this, it begins to work that way, okay? So Vaughn, this does have its advantage in terms of the structure. It's very stable. It does provide us, it doesn't matter which one. Everybody essentially figures out what their best path is to a particular destination, and they take that path all the time. So in other words, these particular links that we have, at least in this path, the rest of them are essentially redundant, and they're not being used right now. Now, if something goes wrong with the main one, well, then we can begin to take something else. Right now, not on that one, but we can actually begin to, actually, we can go here, okay? So we can go across here, and then up to here, and then back down, and you name it. It's kind of weird in how it can actually work. But all that can actually end up working that way. So we end up providing multiple redundant paths, and we can always get through. So Vaughn, that's the idea and goal here when we set this up. It's more about the idea of redundancy and ensuring that we can get good speed, good data, good everything out of this, okay? So Vaughn, that's what we wanted to make sure that we understand here, okay? So in the data tier, when we start talking about 3-tier design, there's also a couple of other things that we need to pay attention to as well. Let me turn that off. And so Vaughn, the way that this normally works out in a data center is that there's two different ways of implementing something like this. There's what we call the idea of top-of-the-rack switches. So Vaughn, notice that at the access layers now, let's pretend like these particular servers I have down here at the bottom edge of the screen, they're actually rack-mounted servers, and at the top of those rack mounts, let's say the first two units or the first 4 units of those, we actually provide different switches up there. And so now each one of these switches in my stacks, they're connected to this switch, and then they're actually directly connected to these switches here with bigger, bandwidth types of connections, and then we still go through the same thing, okay? So that means that we're no longer having to worry about multiple redundancies between every single switch here or every single every single server. And now on the access layers and all the way up here, we have those redundant paths that we can actually use and be able to do what we want to, okay? So Vaughn, this is one of the ways that we can do this. Now, it actually is cheaper in one sense. We don't have a ton of different cables that we have to run everywhere, just like what we were showing a little bit before. But now, Vaughn, when we start doing this, we actually are able to be a little bit more efficient. We use less cabling, a little bit less expensive on that, but we do double kind of the amount of switches that we have. Okay, so this is a fairly common type of topology that you might see in a data center. Now, the other one that you might also see is what's called end of row. Now, Vaughn, when we come to end of row, notice that this one has actually changed when we start talking about the idea of the 3-tier model. Notice that at the access layer, the switches have completely disappeared. Now, every individual server itself is directly attached to the distribution layer. So that means everybody's actually directly attached there. That means a lot more cables. I didn't choose to actually make 4 and 5 cables to show you those connections, but every single one of these is actually directly attached there, and it now begins to function in that particular aspect and way as well. So there's probably a reason why you would choose top of the rack or end of the row, but that depends on the data center and how you would actually choose to do that. So Vaughn, that's the idea when we start seeing something like this as well. Okay, so in that 3-tier model, those are kind of the ones that you want to make sure that you're aware of to do that. Now, Vaughn, like I said, in big data centers where there's a lot of equipment, you may see that, but probably in smaller data centers, in a small to medium business, you might see this instead. It's also what was traditionally known as the collapsed core model. Collapsed core means that the core and distribution layer, they were essentially kind of, collapsed down into one layer, and now we still see those same redundancies here, okay? So Vaughn, in the same manner here, okay, between switches, one of the problems with layer 2 types of connections, right, is that what can happen is I can go from here to here, and I can come back and I can create this loop, okay? And that can actually loop forever, and I might not even know that that's what's going to end up happening. So it is very possible that something like that can actually happen. So instead, when we start doing this, the same thing applies in terms of spanning tree protocol. In spanning tree protocol, it says, yeah, most of these are going to be what? Redundant links. So we still get that same aspect where we get to choose what the best path is through the entire network, but now it just works at 2 layers instead of 3 layers that we were looking at a little bit before. So Vaughn, this model is probably, again, like I said, more towards the small to medium business side of things more than anything else. Now those two, Vaughn, in terms of the 2-tier design and the 3-tier design, these are standard. They are actually good for general purpose types of networks that we need to have access to, file servers, everything else that we need. All that's actually good usage for those things. But Vaughn, there's a problem with doing this, okay? So because the way that spanning tree works, the more links I get involved, the more spanning tree has to recalculate and do all the other things it has to do. We begin to block more links. We begin to lose a lot of the actual different physical ports that we have as we add in more devices to be able to do the connections that we need. So there becomes some problems that we want to make sure that we understand, is that it's not really scalable, okay? It's not super flexible. We can't just change it if something else changes. We'd have to change the entire design of how things work. So Vaughn, we want to talk about our last architecture here just briefly, which is the one that everybody is really kind of focusing in on, especially in the realm of cloud design as well, and that is what we call the idea of the spine leaf architecture, okay? So Vaughn, let's talk about this just briefly here. So here's the spine leaf architecture, and it doesn't really look a lot different, does it? Okay.
No. Well, I mean, there's no connection between the 2 spines like you had in the 2-tier, but we also didn't have the connections. Well, that was not the distribution on the 3-tier.
Right.
Like it had to go up to the core,
right,
and then back down. They didn't talk to each other. So
yeah. So you're right.
Okay, so how is this different?
Yeah. So in the spine leaf architecture, this is designed for the idea that they realize that the 2-tier and 3-tier not very easily expandable, okay, and not very flexible in what it needed to do. The whole goal behind the spine leaf architecture is to ensure that we don't have to deal with, spanning tree, okay, is what it does. So even though we have redundant links now, okay, notice that for us here, we're not actually getting a loop that actually comes all the way back to this guy, okay? Now, in theory, I could bounce from here on this left switch up here, and then go across here, and then come back here, and then go all the way over there again. Maybe I could get into a loop that way. But Vaughn, by that point, what actually ends up happening, so let's say that between these 2 guys here, okay, I can actually go in any one of these patterns, and I can get there essentially in, 2 different switching hops is what I can do, right? So here's the first one, and here's the second one. Actually, I'm like, here's the first one, here's the second one, and then we're down. And so it doesn't matter which of these links I take, I can do that. but it's not looping me all the way back to the leaf. Okay, so it doesn't matter which one of these we end up taking. If I go here, I can come here and then come down. If I go here, I can go up here to the right-hand side one and then come down, and I can still get here. Okay. Now, the advantage of this Vaughn, which is kind of strange for us, is that it doesn't actually ever put us into that looping situation. So spanning tree itself doesn't come into play in terms of the spine leaf architecture. Okay. So even if my network continues to grow, because every single leaf device that we have is directly attached to every spine device, notice we're not linking these. We're not going to get into a loop between something like this, okay, where it actually constantly loops between these two switches here. Okay, it's not going to do that. So if I add in, because I have more different endpoints that I have to do. So Vaughn, if I add another switch in, okay, notice again, it doesn't give me that ability to create that loop once again. Okay, so I can continue to add in switches, and I'm never going to loop with these other switches down here, nor with anybody else. So I can continue to add in more and more different physical servers in my rack, and I don't really have to change too much to do this. I have to add in some cable, I have to add in another switch here, but once we do that, there doesn't really come that point where we have to actually do a lot. Now, when I say that, Vaughn, if I start adding in multiple racks of them, I need to also be able to change in terms of the spine. But now if I change the spine, now notice that this is what we also have here, Vaughn, is even by adding in an additional switch, I'm not going to ever get into that loop that ends up happening where the data is coming back.
Adding another spine.
Yep, adding another spine,
okay,
sorry.
So when
yep.
you add at the top, because again, they're
Yep.
all...
They are connected just
Yes.
about, but they're not directly connected. The leaves are never directly connected here.
That's what I'm trying to say.
Happening. Yeah. So we're not going to really ever get into that situation here.
Okay.
Now, Vaughn, the neat thing about the spine leaf, though, okay, unlike the original traditional two models that we talked about, right? On those, Vaughn, when we start taking a look at something like this here, oh, let me go all the way back, okay? These are devices that we generally have to configure each on their own, okay? Access layer switches, again, we have to manually configure them to do that. But in the spine leaf architecture, though, there's something that we call the ACI, okay, which is the Cisco ACI, which stands for the Application-Centric Infrastructure. And Vaughn, when we talk about the idea of applications, well, Vaughn, you're more familiar with the idea of the web development world. When we talk about the idea of applications, we're really talking about some type of programming that we can essentially do. And Vaughn, what this ends up turning into, okay, is it actually ends up making essentially the whole thing, the spine leaf together. It ends up working as if it's one big gigantic switch is what happens. So in other words, the Cisco ACI allows us to treat the whole thing as one big gigantic switch instead of actually seeing two layers of devices.
Because it just sees connections. It
That's
just
all
sees
it
that
does.
I'm going to direct you to where the connections are coming in and out
That's
from as one entity rather than kind of splitting it up onto different responsibilities.
Right, yeah. So that's what we can do. Now, can you add in layer 3? Yes, you can do all that stuff. So it doesn't really matter. The reason why is, Vaughn, if we have this as our underlying topology architecture here, in the data center, we can actually create overlays. In other words, software overlays that we say, you actually have this underlying architecture that's not going to ever loop. But in software, though, what can we do? We can actually create layer 3 routes if we want to. We can do all the other things we want to. We can create VLANs, VXLANs. We can do all that without ever having to change the underlying infrastructure and technology, because we now have a loop-free type of topology underneath it. And that means everything can actually work that way. So this is the advantage of actually going to that spine leaf architecture that everybody's really essentially turning to at this point. Okay. So Vaughn, in terms of the data center, we want to make sure that we covered this idea fairly completely, that we have a good understanding that the layer 2 and layer 3 designs, are we still going to see them in the future? Probably. The very fact is, small to medium businesses, they're not going to change over to this really quickly, okay? And even large businesses that already have that 3-tier infrastructure already set up, more than likely, they're not going to change over too often, as far as switching over the entire network. But if you end up working in that place where you are seeing this, where you're actually having the idea of the spine leaf architecture, it's because it is a rapidly changing environment. It gives you flexibility, allows you not to have to worry about what the actual data is going to be as it travels across and how far it has to go. The reason why is that no device is ever any farther than 2 switching hops away. So that's why we can actually treat it, like I said, like that one big switch within our entire rack or within that facility to be able to do what we need to do to manage all those connections together. So Vaughn, that's what we want to at least understand in terms of the networking architectures that we're seeing here. And the future is probably going to be more of that spine leaf. So Vaughn, that's probably a good overview at least of the different topologies and the architectures that we've been talking about.
It sounded like a good overview of possible exam questions. So pay attention. And if you need to, watch it again. That's why we do what we do. So thank you so much for joining us. But we're going to go ahead and sign off for IT Pro TV. I've been your host, Vaughn Smith.
And I'm Ronnie Wong.
We'll see you soon.
Thank you for watching IT Pro TV.